Consider this electrical circuit. We have a single light bulb wired in parallel to two separate wall switches, A and B. Because of the parallel wiring, if you flip either switch A or switch B, the electrical current finds a path to illuminate the bulb. This physical setup models the concept of logical addition. In digital electronics, we perform this operation using an OR gate. It takes multiple inputs, like our switches, and evaluates them to produce one definitive output. To analyze this mathematically, we assign numbers to the states of the circuit. A state of 0 represents off, meaning the switch is open. A state of 1 represents on, meaning the switch is closed and current is flowing. Translating this behavior, where a light turns on if path A or path B is active, into binary ones and zeros, allows us to see how computers make basic either-or decisions. This is the logic symbol for the OR gate, defined by its curved back where inputs A and B enter. The output is expressed by the equation y equals A plus B. The plus sign denotes the logical OR operation, evaluating pathways, not arithmetic. This symbol and equation allow engineers to millions of either-or pathways onto microscopic silicon chips. We can map every possible state of our switches onto a truth table with inputs A and B and output Y. In the first row, both switches are open, 0 and 0. With no path for current, the output is 0. For the next two rows, we close one switch at a time. If input A is 0 and B is 1, the light is on, so the output is 1. Similarly, if A is 1 and B is 0, the output remains 1. In the final row, both switches are closed, input 1 and input 1. What is the logical result of 1 plus 1? In Boolean addition, 1 plus 1 equals 1. If you close both parallel switches, the light turns on. The physical state of a bulb being on cannot exceed simply being on. Building the truth table through this logical progression demonstrates how hardware functions, making rote memorization unnecessary. Streamline your analysis by observing one specific pattern. For an OR gate, if any one input is a 1, the output is a 1. Applying this logic directly ensures fast, accurate results during an exam or when debugging a circuit. This setup works exactly like a car door alarm. The alarm triggers, resulting in an output of 1, if either the driver's door or the passenger's door is left open. Let's look at a common board exam question. If A equals 0 and B equals 1, then what is the value of A plus B? Using the pattern we observed, we see that input B is a 1. Because a single 1 in an OR operation results in an output of 1, we can determine the answer is 1 immediately. Understanding how the physical switch relates to the abstract symbol provides the clarity needed to solve digital device questions correctly.